So today we're learning about reaction rates. So you want to make sure that you get a copy of this if you've not already gotten so. Reaction rates. What do you do in your daily life to speed up or slow down reactions? Those at home can play along. Landon, what do you do in your daily life? You plan a schedule. What does that have to do with chemical reactions, though? Those at home? Speed up or slow down chemical reactions. What is something that you do daily or you use daily to speed up or slow down chemical reactions? What do you do driving that speeds up or slows down chemical reactions? Pressing on the gas. What does pressing on the gas do? It puts more fuel through the engine. So that's a higher concentration of fuel, which makes that reaction go faster, which creates more energy, which lights the pistons faster and makes the car go faster. There we go. There's one. Pressing on the gas increases concentration, burning more fuel faster, making the reaction faster, which makes the car go faster. What's another thing we do? To speed up or slow down chemical reactions. You got one? You think you got one, Ann? What do you got? Blow drying your hair. Unfortunately, that is just a physical change. That is not a chemical change. You got something like that? Chemical reaction, either speeding it up or slowing it down. You feel comfortable because you got the gas one, huh? Yeah? Got anything else? Let's think about slowing down reactions. What's one of the most reoccurring costs that you have in your household each month? Reoccurring costs in your household. Water bill, all right? Not the one I'm looking for. Electricity bill, all right? Not the one I'm looking for. Something that you spend money on every week, probably, that you don't want to undergo chemical reactions. Home players, what do we spend money on each week that we don't want to undergo chemical reactions? Food. What do we do? Thank you, Sydney. What do we do to slow down the chemical reaction rate of food? We do what? Refrigerate it. We refrigerate it or we freeze it. Right? Well, let's handle the slowing down of the rate first. We take the food and we slow down the reaction rate by Freezing it. Amani, you are at home. Okay, cool. Or cooling it. What that does is that slows the rate. So far, Landon told us increasing the concentration of a reactant, like pressing on the gas, makes the rate faster. Taking energy away from the reaction makes the rate slower. Now, it was brought up, what about if we're baking the food? Well, we are increasing the temperature. So we are trying to enhance or speed up these reactions. For example, when we take an egg and put it onto a hot skillet, we're denaturing that protein. We are doing that at a quicker rate. If the pan is hotter, that egg will turn less slimy and more firm and white much, much faster. Right? So I got Cassidy, Kennedy, and Ka. KKK. All of these guys are gone, right? Cassidy, actually Cassidy's with a C. Kennedy and Ka. Michaela is home. Sydney is at home. Amani, you're at home today? Hopefully everything's going well with you. All right, go. So far we've got two things. We can affect the reaction rate with temperature, and we can affect the reaction rate with concentration. Anything else that you can think of to affect the reaction rate? When you're cooking something, do you want stuff to be big or small? Which one cooks faster, big things or small things? Small things cook faster, don't they? Small things cook faster. So if we cut up a bunch of things into smaller pieces, they will cook faster. What that is called increasing the surface area. For example, if we have a whole cow and we're trying to cook a whole cow, we can only heat the outside. If we cut that cow up into more and more tiny pieces, steaks, chops, whatever, then we can cook that cow much faster. That's increasing the surface area. Increasing the surface area. All right, then. Let's take a look. Right, Landon? If I take and pick up a cow and I throw it at you guys, I probably only hit one of you. If I take a cow and grind it up into a bunch of pieces and I have a bucket of cow, probably hit more than one, right? More surface area. All right. Share screen. All right. So if we take a look, this is called the kinetic theory. Where's my pen? So kinetic theory. Kinetic theory or collision theory. Reactants must collide in order to form products. So reactions are a result of these collisions. Factors include collision frequency. If we have more particles, they could collide more often. If the particles are moving faster, they could collide more often. If they're moving slower, collide less often. That's why freezing something prevents reactions from happening. Prevents them in the microbes and stuff like that that can spoil our food. Right? They can't reproduce as quickly, and then they can't spoil the food as fast. Orientation. Have you ever gotten that garbage handshake from somebody and you're like, what is this? Why am I involved in this? Get me out of here. Right? Like they grab it weird or something like that. That's the same thing with when it comes to reactions. The particles must collide with proper orientation. For example, If I want to go like this, I have to collide with proper orientation. I can't do it like this. That doesn't work. It has to have a proper orientation. The other thing is it has to have a certain amount of energy. If somebody comes in for a handshake or whatnot, all slow, then you grab too fast and then you're given the garbage handshake. So if I do this, but it's not fast enough, I may only get to here. And then whenever I collapse this, it doesn't feel the same. We got to have enough energy, proper orientation to get to this, right? So a successful collision is any collision that forms products. Most collisions are not successful. Either they collide without enough energy, they collide with the improper orientation. All of these different things. All of these different things. So these are things that you need to make sure that you are aware of. What factors affect the rate of reaction? This is big. This is big. All right, let's see if I got these reaction rate movies that I want to show. Nope. All right, cool. I'll get them. So temperature, huge. Temperature is huge. As the temperature is raised, the reaction is faster. For every 10 degrees Celsius, the reaction rate doubles. So if the reaction rate is 0.0012 at 20 degrees, what is it at 30 degrees? What is 0.0012 doubled? Very good, 0.0024. Then what if we go up to 40 degrees? Louder? 0.00 what? Nope. It actually doubles. You just added 0.0012, but it doubles from 0.0024. So it's 0.0048 at 50. Point 0.00996. Doubles every single time. The next thing is the nature of the reactants. So we know that certain things react more. For example, the alkali metals are very reactive. The alkaline earth metals, not so much. Not so much, right? So all of these different things are factors that affect the rate of reaction. Factors that affect the rate of reaction. Concentration. This is one that Landon noted earlier. Landon said, oh, okay, yeah, if you take a look, if I press on the gas, more gas goes in, higher concentration in gas, more reactants will yield to the formation of more products because they can collide more often. We know this. More gunpowder, bigger or smaller explosion? Bigger, right? Bigger explosion with more gunpowder. More, more TNT. I'm trying to sit here and think like anytime we add more, right, we're going to get a faster reaction rate. How about concentration of an acid, for example? Concentration of an acid will react more vigorously, right? You guys ever seen that Skittles commercial? Yes, no, maybe? Let's take a look here. I'm sorry, it's a Starburst commercial. Hopefully you guys can see that okay. Let's take a look.
Whoa. I got it.
Right? How funny is that? They both just reached into something where, what does it do to your arms because of the concentration? Dissolves them, right? They both reach in to get the Starburst because Starbursts are that good. In reality, there is no acid that could dissolve your arm that quickly and painlessly. But funny commercial nonetheless. Last thing, catalysts. You've heard of catalysts in the past. In your body, we call these enzymes, like peroxidase, the thing that breaks down peroxide, or helicase, which breaks separates the DNA double helix, or amylase, which breaks down starches as soon as they're in your mouth. All of these different things, those are catalysts. Now, the cool thing about catalysts is that they speed up the reaction, but they aren't used up, which means that they can be used over and over and over again. Heat is not a catalyst. Heat determines the rate of reaction by speeding up the particles, one, and two, giving them energy. Questions about factors that affect rates? All right, what I would like for you to do is at home, because I know that the movies do not work very well at home versus here, is I put a movie on for today. It's 5 minutes long, and it covers these reaction rates. I would like for you to make sure that you watch that. Also, today, all grades are finalized. If you've done something between now and Sunday, then you want to make sure that you let me know if you're turning in some of that old work. The grades are all up to date in my eyes. If something is wrong or incorrect, make sure that you tell me over the next week and I will change it. Take a look at those grades. Keep in mind that I don't have due dates on a lot of the assignments, only tests and quizzes. The other thing is that they've gone back to reverting to, if you pass the final, you pass the class. Make sure that you understand that as well. That's not a position that you want to be in. The final exam will be a no holds barred comprehensive final for the entire year. So make sure that if you are going to try that you are prepared for it. The final exam has been put up here. So you have the final review, so you can go through that. That's what I've got for today. So please make sure you watch this movie at home. We're going to watch it in here as well. Have a great day, guys. Take care. I can't believe you guys don't like Starburst commercial. I think it's hysterical. It's weird.